Alright, so what we're doing for the next several sections is finding specific points that are formed by segments in a triangle. And we'll talk about each of those segments as we go. There are 4 of them, and the way that you find each is pretty similar. So you want to keep them straight. Okay, so today we are starting, and tomorrow I want you to bring your compasses. We're doing in-center and circumcenter. In-center and circumcenter.
Is this still with circles?
I'm about to define them. Alright, in-center. What you need to know is that the in-center is found, or is, the center of a circle that is inscribed, hence the word inscribed, in a triangle. Or actually any shape, but in this case a triangle. And the circumcenter is the center of a circle that is circumscribed. Around a triangle. So in the in-center, you're going to have a triangle, and you're going to have a circle inside of it because it is inscribed, and there's its center. So that would be the in-center. In a circumscribed circle, we have a triangle, and each of these vertices are on that circle. So the circle is like going around it, and your circumcenter could be inside or outside of the triangle. So that's going to be something very important to know. The in-center is always inside the triangle. The circumcenter can be on, inside, or outside the triangle, just depending upon it. But notice, see, circumcenter, what we have here, the circumcenter is the center of the circle that is circumscribed. The circle is around the triangle, not inside the triangle. So that's one way that you can keep those things straight. Okay. So, the question is, of course, well, how do we find each one of these things? So, in-center. To find in-center, we're going to bisect the angles. Now, that's something that we've actually done before. And you want to leave some space there so that I can show you. And for circumcenter, we are going to bisect the sides. Now I only need to bisect 2 angles or 2 sides. I don't need to do all 3, although I could. So let's say I have a triangle here, and I want to find the in-center. Now we can do it graphically, at least circumcenter we can do graphically. But in-center, we're basically going to have to use a compass and protractor. So I'll walk you through the steps that you would do. We would choose any 2 angles. Let's say I choose this one, and I choose this one. Okay? So I choose this angle. I'm going to bisect this angle. So remember, we take our compass, and I'll draw a quick compass in green, you know, okay, and here's our,
No.
compass.
Wonderful.
No, it's a beautiful compass. I'll get it in the correct color so that, it's not multicolored there.
Not tacky.
Okay, anyways, there's my compass, all right? And here, what you're going to do is you're going to swivel that, and it's going to hit these two sides, right? And then I'm going to pull out a little bit more, right? And then from each of these points, I'm going to swivel again. And once I'm done, I'm going to connect, and I'm just going to draw it right through. And that angle should be bisected, so this is two equal pieces. Then I'm going to do it again at one of the other angles. It doesn't matter which one. So I'm going to erase these extra steps. Oops, undo that. Just so that it's clear. Okay, I'm going to do this one. And I pull out my compass, and I draw this. I do my arc. It hits on two pieces. I pull out a little bit more, and I do my arc again from each of those points, and then I connect. And I should have bisected that angle. Okay? So, what has happened is I have now found the incenter. This is the incenter. Now, the incenter is going to have several properties. So I have this circle, and that is now inscribed in there, if I were to draw it. Okay, notice where this circle hits. It'll hit here, it'll hit here, and it'll hit down here. Okay, it hits in three spots. Besides finding the incenter, what we need to be able to understand about this incenter is that if I were to draw at each of these locations where it hits a radius, all of them should be the same length because they're a radius. All the radii are equal. So each of these are the same. All right, let's do a circumcenter. Now remember, an incenter is the center of an inscribed circle. Gentlemen, pay attention. The circumcenter is the center of the circumscribed circle. So the incenter is inside the triangle. The circumcenter may be inside, outside, or on, but the actual circle is outside. It's around the triangle. To get this one, I'm going to bisect the sides with perpendicular bisectors. So again, I'm going to take my compass and I'm going to choose any two sides. In this case, I'll just do these diagonal sides, but it doesn't matter. I'm going to do the two that are going to be the easiest. And basically, I pull out more than halfway, and I do an arc like so. Right? And then I do the same thing over here. I do the same thing. I pull out more than halfway, and I make my arc. All right? And then I connect those points. So when I connect those points, I should get a perpendicular bisector. And yes, I know I erased that. It's just going to get too messy if I don't erase it. I get my perpendicular bisectors. And where those two things meet, that is my circumcenter. So that's the center of the inscribed or circumscribed circle. So the circumscribed circle, it doesn't look like a circle because I'm just not a very Greek artist.
So did you just say you bisected two of the lines?
I bisected two of the, yes.
Okay.
So, I'm sorry. Can you do that one more time?
Yep. Okay, so there's my,
Will they already have the
there's
circle?
my circumscribed circle, and that's the center of it. So all I'm doing is doing what we did. Remember when we had a segment? Here. I have a segment. Boom. And I say bisect that segment. You take your compass, right? And you take your compass at each end. You pull out more than halfway, and you remember you swivel, and you swivel from both sides, and you get that. And then what do we do with these 2 points?
Draw a line through them.
We connect them. Okay, this is the perpendicular bisector. It cuts this into two halves. I'll talk you through it once more because I see glazed eyes like you've never seen that before. So once more, we have done this before where we take a segment and we bisect it with our compass. We take our compass, see, compass. There's our compass. We swivel this compass around this point so that we have, no, I don't want that, undo that. Remember, swivel, and then I swivel from this, I pull out more than that, I swivel, and then I connect these 2 points. You with me?
Yes.
Okay, so over here, when I have the triangle, I just do that twice from any 2 sides.
Could you draw like the actual arc on the?
Yeah,
Okay.
and you should. Okay, now, I'm gonna talk about some properties of this circumscribed circle. So we found our circumcenter. Now, this point, each of these vertices. Okay? Now, if this is the center, what is this that I just drew?
A radius.
A radius. And just like up here in the center, all radii are what?
Equal.
Equal. So all of these sides are what?
Equal.
Equal. They are just drawn from the vertex to the circumcenter. So again, all radii are equal. But look at the difference. See, here the radii are not drawn to the vertex, are they? But down here, for the circumcenter, they are. Now, we can do circumcenter on a graph. So let's say I have a triangle, and I'll do an easy one, I hope. Let's see here. I want to make it easy, so. Okay, yeah, that'll be an easy one. Okay, just follow along with what I'm doing. I'm going to bisect these 2 sides. Now, even if it is on a graph, I could plot it and do it by hand with a compass, but I'm going to be off by a little bit. You paying attention there, Clint? Focus, look up, please. Thank you. All right, so I'm going to bisect any 2 of these sides. I'm going to, of course, do this one, because that one's flat and it's easy. Here's the middle, right? I don't even have to do anything with my compass. There's the middle, and I am just going to draw straight up. So there's the perpendicular bisector. Now I need one more perpendicular bisector. So if I choose, say, this side, notice the slope, up to right 1, up to right 1. So that one has a slope of a half. So if I wanted the perpendicular, remember when we did perpendicular lines, we flipped that around and then we switch it. So here's the middle. Do you see this has the middle? Okay, go down 1, right 2. Down 1, right 2. And that gives me the perpendicular bisector. I just need to find that. Now notice, this point right here, if we're doing a perpendicular bisector, that's a midpoint. So where do these meet? Right here. So what is this? It is not, it's the circumcenter. Alright? So that's the center of the circumscribed circle. What's the circumscribed circle? Well, it's going to be this circle that hits all of those, okay? Well, how do I even draw that thing? Well, pull your compass out to a point of the triangle, and then just swivel around the circumcenter, and you'll get the circumscribed circle. And this is its center. Now, what do I know? I know there's a lot of pieces of this diagram, but if I draw from the circumcenter, what's that I just drew?
A radius.
So all the radii are what?
Equal.
Equal. Okay, that's going to be important to remember. All right, get your whiteboards, and I don't know how much time we have.